In the first video in this series on how the two transistor flasher circuit works, we built this circuit. So if you haven't watched that video, it'd be a good idea to go watch that video now. In the second video, we're going to look at some basic principles or how things operate in order to explain this circuit. This is a cheap voltmeter, and it's got some wires connecting over here with pins on the end of the wires. And what we're going to do is we're going to plug this wire in there like that, and then we're going to plug this wire in by the base. Now what's interesting is if you keep an eye on the voltmeter, you'll see that the voltage is dropping deep into negative territory. It's dropping down to about 3.5 volts or thereabouts with each flashing cycle. How do we get a negative voltage in the middle of a circuit that operates from 0 volts up to 9 volts positive? How do we then jump down below that value with a completely negative voltage? The other thing we can have a look at quickly, I'm just going to move this probe wire of this cheap multimeter, and I'm going to add it into where the collector leg connects up to the LED. So the collector of the transistor. And now what you'll see is we're not going down deep into negative territory. We're just almost reaching 0 volts before the volts goes up again. So the volts is going up and down. What we need to do now is we need to understand how a transistor can be used as a switch. This little device that you can buy online for a few dollars, it's called an M tester. So we put the part in there and then we activate this thing. And what it does is it identifies the part. So you can put different parts in here. If you get no reading, it'll say no reading or unidentified part, which basically could indicate a fault. But what you'll see here is that this has identified the part that I put in. It's a little black part with 3 legs called a transistor, and this tester has identified it as an NPN transistor, and it's giving various readouts there. Let's see what happens if we put an LED into this tester. So it's identified it as a diode, so it won't tell you specifically that it's a LED, but it has identified it as a diode. Let's now put a capacitor into this device. So there is our capacitor, and we initiate the test. It's telling you it's a capacitor with some values. Here's a resistor. Both legs are connected to 1. Let's try again. And looking at the color code on this resistor, we know that it's a 680 ohm resistor. If you look down the gap there, you'll see there's 1, 2, 3, and then 1, 1, 1, 1. And those identify the pin numbers of the ZIF socket. There's the transistor. Now what I'm going to do is I'm going to bring up a circuit diagram of the transistor. And I'm also going to show you a basic circuit that we can use to test the transistor, but also to learn more about transistors. Over here we've got a little test circuit, and this test circuit consists of a voltage divider. This is what the circuit diagram might look like. So there's our transistor with base, collector, emitter legs, and notice the base is connected to the variable resistor, the slider pin or the middle pin of the variable resistor. If we look at this drawing, you'll see this is what it looks like if we look at the actual physical parts. This is what a slider variable resistor looks like. This is what a fixed resistor looks like. This is what a rotary variable resistor looks like. So these might be used as a volume control on a mixing desk with slider controls. This item might be used as a volume control in an audio amplifier with a big nice volume control knob. This item here is a variable resistor, which is quite useful because it can be plugged directly into a breadboard without needing to solder additional wires on, like in this instance or this instance. So I can put a breadboard over here. We can put a transistor into the breadboard. So we've got, at the top of the screen, we've got the collector. In the middle, we've got the base, and at the bottom, we've got the emitter. So we can put this variable resistor with the middle pin in the same row as our transistor. Then we obviously need to connect over the gap in the middle to the base pin, an LED into the breadboard, connecting to the collector leg of the transistor, just like in the schematic diagram, which I'm going to put up now. We're putting in a current limiting resistor because we're using a 9-volt battery here, and an LED doesn't like to go much over 2.75 or 3 volts or thereabouts. Try to use a quality battery like an Energizer. So the positive side of the voltmeter we've connected to the base pin, and then obviously we put the minus side of the voltmeter to minus. So we're measuring between minus and the base, and what you'll see, we've got a voltage there of about 0.79, 0.8. Now as I turn this down, you'll notice round about 0.7 volts the LED comes on bright. So what we're seeing there is when we apply a voltage of around 0.7 volts to the transistor, the base is biased positive, and it completes the connection between collector and emitter, which allows the LED to glow brightly. So that's how the switching action of a transistor works. We're not going to get into atomic theory and doping of silicon and how does a semiconductor work in this video. I have made videos about that in the past. Maybe in one of these future videos in this series I can explain a bit about that. Suffice it to say that around about 0.69 or 0.7 volts or thereabouts, the transistor is on, and if we turn that down, we can clearly see that at 0.67 it's dimming a bit, and if we adjust down further, 0.64 is dimming down, and at 0.49 it's not really lighting the LED at all. So that's going to become quite important in explaining how the two LED flasher circuit works. If we bring the parts tester back and we put this transistor in to the zero insertion force socket and we press the go button, and now what you'll see is it says VF equals 689 millivolts, which is interesting. HFE is the gain of the transistor, but the VF is the point at which things happen. So 689 millivolts is very much the same thing as 0.689 volts. What we discovered is that the LED in our little circuit switches on at about 0.68, 0.69 volts. I hope this has been useful. You might want to obtain one of these M testers. It's just a useful troubleshooting tool, but it's also quite fun from an educational point of view, and also understanding if the parts in your junk box or your spare parts box, if they're still good or bad, and sometimes you can even use this to identify what part it is. So we've got a yellow wire there, a green wire, and then a red wire. So now there is our voltmeter, and let's do that. The green wire is connecting to the base and the red wire is connecting to plus. Now if I squeeze a dry finger onto these wires, you will see the bias voltage goes up to 0.6 and the LED is just lighting dimly. But if I put this wet damp finger, so there the voltage on the base went up to 0.68, which corresponds to that voltage that we picked up on the M tester. So we've got a small amount of current going through my finger and a large amount of current going through the LED. Now let's see what happens if we touch a wet finger to the base. So now we've got the base and ground, and we're touching a wet finger there. Interesting. We get a little bit of a negative sign popping up on the voltmeter, but basically nothing happens. So the next question you might be asking if you're watching this video is, do we need a transistor at all? What about if we take the transistor out of there? So now we're touching these two wires together. So where these wires are connecting is where the collector and the emitter of the transistor was connected. So this is performing the same function as the transistor was performing when the transistor was acting as a switch. But what we discovered with the transistor is by putting a tiny amount of current into the transistor using a damp finger, we could switch the transistor on, which switched the LED on. Now let's try doing the same thing but without the transistor in the picture at all. So we're just going to see, can we light up this LED with a very wet finger? Okay, so we can. That's quite interesting. Can we light the LED with a dry finger? Because remember, with the transistor, we could switch by pressing hard with our dry finger on the base. We could actually switch on the LED. So that doesn't seem to be possible. So that proves the principle that a very small amount of current into the base can cause a lot of current to flow between the collector and the emitter. But in the next video after this video, we're going to look at a little day-night switch using a light-dependent resistor and a transistor and an LED. So for purpose of clarity, I thought we'd just have a quick look at this variable resistor, which more closely resembles the variable resistor in this circuit diagram that's up on the screen now. So notice how the value is changing. It's going all the way up to 12 on that side, and it's coming down and down, down and down until it's almost no resistance at all. Right folks, so what we've done now is we've got 2 voltmeters set on the resistance measurement ranges. And if we put the slider in the middle, you will see that there's a value of more or less 6 across this half and that half. Essentially, it's a variable resistor, but it's actually being used here as a voltage divider. As we slide the slider along, you'll notice the amount of track here is increasing, the amount of track there is decreasing. So as the distance of carbon track inside of this variable resistor decreases, the resistance decreases until it becomes a very low value, if not 0, when it reaches the full extent of its travel there. But the total over here is 12 kilo ohms. So notice how as we slide this along, the resistance over here is increasing and over here it's decreasing. In the middle, it divides the overall resistance in half. If we switch these over to a voltage function, there and here, now we have to introduce a voltage using the battery. So we put a voltage now across the variable resistor. Watch what happens as I move the slider along. We can see how the voltage in this meter over here is increasing and the voltage over here is decreasing. It's a very, very important principle because this is how we can bias the input of a transistor to switch it on and off. If we set this slider to round about 0.7 volts, we can switch on our transistor. So as we shift this along round about there, that's the point. Now look at the voltages. So when the transistor comes on and starts conducting fully is around about 0.68. So I hope that that's been a little bit interesting. Try and set this up on a breadboard at home